even though you don't need the whole part of the model yet, we're just going to write the whole thing now, so you only have to learn it once. It's written in feet and in meters, so the version in feet is negative 16t squared plus v sub o t plus s sub o. That's the version in feet. And we're going to define what all these terms mean. And then in meters, the only thing that changes is the number in front of t squared. So that becomes a negative 4.9. And v sub ot and s sub o is the same thing. And we talked about the fact that these numbers here...
Teacher, Student Tech will be in Mr. Klingbeil's room today after school in about 5 minutes or so.
We also talked about the fact that these numbers come from the effective gravity, because in the general form, this number is g divided by 2, where g is the effective gravity. And I don't know if you guys have learned that yet in the science class, but effective gravity in feet is 32 feet per second. So 32 divided by 2 would be 16. And then in meters, it's 9.8, so that's where those numbers come from. Because this height model has to do with any object that's thrown down, thrown upward, or dropped. Any type of motion through the air. So to define our variables, this all goes in that box at the top. S of t is our desired height. So if I told you I wanted something to hit ground level, then your desired height would be 0, because that's 0 at ground level. T is time. V sub o is just a way to write a variable. Instead of just v, we write v sub o because it means your initial velocity. So if you just had a v, it would just refer to the velocity, the initial. And then s sub o is your initial height. Okay, so we just applied it to one example. I don't know what number is that example? 4? Okay. And in part A, we, I think, looked at an object that was dropping. So, yep. So it asks how long. If you're asked how long, and that's what you're trying to find, what variable does that refer to that you have? When I ask a question, how long does something take to fall? Am I asking for desired height? Am I asking for a time as an answer?
Oh,
the time, yep. So we're looking for t, which means in my height model, I should have something to plug in for everything else. Because I think it's just a penny that's dropped from the top of the building that's described. So first of all, you have to decide if you're going to use the one in feet or in meters. Feet, because the building's given to you in feet. So we're going to write down s of t equals negative 16t squared plus v sub ot plus s sub o. We know we're looking for time, so I'm not going to be able to plug anything in for time. So I should have something to plug in for everything else. I'm looking to see how long it's going to take to hit the ground, so my desired height is going to be what? Oh. Sorry.
Alright.
Yeah.
So what was the question?
The question was, so if I want the object to hit the ground, s of t is my desired height. So what's the height at ground level? What would you plug in for that?
Ground level?
Yeah.
Zero?
Yep. So we're going to plug in 0 for s of t. I'm looking for t, so when you just have a plain t, that has to stay, because that's what I'm trying to find. What's my initial velocity if I'm dropping something? How fast is it going if I drop it? If I have an object, look at my hand. If I have an object in my hand and I just drop it, how fast is it going in my hand if my hand is not moving?
How fast
is this object going? If I have a remote, how fast is that remote going?
When you drop it.
Before I drop it.
Zero. It's not going.
Yeah, it's not going off.
I thought you meant once you drop it.
Oh, once I drop it. That's what we're trying to find, yeah. So I'm going to put in 0 for v sub o. T stays the same, because that's what I'm looking for. And then S of O is my initial height, so how high is that building? Where I'm dropping from? 1450. Okay, so in the middle here, 0 times anything is just 0. So I'm going to simplify this a little bit. That just kind of disappears because that just becomes nothing. And then it becomes like all the other problems that we've been solving in class where we try to get t squared by itself. So what's the first thing you have to do there to get t squared by itself?
You have to subtract 1450 from 140.
Yep. Good. And then do what?
Divide by 60.
Good. Okay, and if we do that, the negatives cancel out. And then what do I have to do to solve for t?
Square root it.
Yeah. Okay, so I'm going to just figure that out right here. So I take the square root of 1450 divided by 16. Getting 9.52. What are the units on that?
P.
Well, what were we looking for in the beginning? To answer the question, how long? Time. So it has to be some kind of time unit.
Oh, so it was decimal.
Okay. So it takes 9.52 seconds for this object to drop from that height. And then in part B, it asks you how fast. So now we're looking for a velocity. But it actually gives me a new formula to find that velocity. Isn't it s equals 32t? Okay. So then we're supposed to use this formula.
What does it look like?
What?
The notes. Chapter 3?
I found them. Didn't you get my email?
No.
Oh, I found them. It was in my stack of
Of
paper.
course it was.
Think so.
You said them last time.
That's a little weird.
It's creepy.
Thought I filled that out.
I had this one first.
She's working on a task. You can't help her. Stop asking for help, Betty.
You know me. Yes, Brett.
No,
So
he's
if you-
also working on a task.
So if you factor 1 minus sine squared x into 1 plus...
Yeah.
Relax. He's helping you.
Like all along. He's like,
Alright, so in this new formula they give us, if I want to see how fast it's going when it hits the ground, that's how long it takes. Right, Jake?
Yeah.
Okay, so I just plug that in for t. And then that's going to give me the speed that it's going.
Oh, that's what you gotta do.
Yep.
Holy crap.
32 times 9.52. And we get 304.64. Now what are the units on that if that's a velocity?
Feet per second.
Yep. And that was it. So it's just knowing the height formula, or the height, not the formula, the height model, and then plugging the values in that belong there. That's all we talked about.